Alright, in this video we're going to talk about solving linear systems by graphing. So what is a system of equations? It is when you have two or more linear equations. What is the solution to a system of equations? So the solution is the ordered pair x, y at which the lines intersect. Now, you can have several different types of solutions. You can have, when the lines intersect, you have one solution. You can have, and your solution is the ordered pair where they cross. You could have parallel lines, so there's no solution. They're never going to cross. Parallel lines always have the same slope, but different y-intercepts. And you could have identical lines, so then you would have infinite solutions, because every single point on that line is a solution. Alright, solving by graphing. So first thing we're going to want to do is make sure our equation is in slope-intercept form, which is y equals mx plus b, where m is our slope and b is our y-intercept. So here's my first equation, my systems of equations. I have y equals x minus 8, and I have y equals negative 2x plus 1. So all I'm going to do is graph both of those on the same coordinate plane and try to see where they intersect. So they're both written in slope-intercept form. The first one, my y-intercept is negative 8, and then my slope is 1. So I'm going to go up 1 over 1, and I'm going to draw a line through those 2 points. My second equation has a y-intercept of positive 1 and a slope of negative 2, so I'm going to go down 2 over 1. Once I have 2 points, I can draw a line. I strongly suggest you use a ruler when you're working these out on your own, or you can use an edge of another piece of paper or something so that you can get a kind of straight line because you're looking for where they intersect. So right there, that point where they intersect is my solution, and the ordered pair is 3, negative 5. Whoopsies. 3, negative 5. Okay, the next one. Y equals 1/2 x plus 9 and y equals negative x plus 6. They're both in slope-intercept form. So my first one, my y-intercept is 9. My slope is 1/2, so I'm going to go up 1 over 2. Then I can draw a line through those. My other equation has a y-intercept of 6 and a slope of negative 1. So I'm going to go to 6 on the y-axis and then down 1 over 1. Draw a line. I can see that they intersect at the ordered pair negative 2, 8 is my solution. Number 3, negative 3x plus y equals 8, and negative x plus y equals negative 2. So these are not in slope-intercept form, so I'm going to have to change them first. They're both written in standard form. So to change it, I'm going to add 3x to both sides to get the y by itself. I get y equals 3x plus 8. On the other one, I'm going to add x to both sides, and I get y equals x minus 2. So my y-intercept is 8 on the first one. My slope is 3, so I'm going to go up 3 over 1, but that doesn't quite fit on my graph, so instead I'm going to go down 3 and to the left 1. Once I have 2 points, I can draw a line. And it's always a good idea to kind of make sure your line goes the whole length of the graph, because sometimes they intersect right there at the bottom. And then my other one, my slope is negative 2, my y-intercept is negative 2, and my slope is 1. So go up 1 over 1. So you can see there I should have kept going because it makes it kind of hard to see where they intersect. All right, but the intersecting point is negative 5, negative 7. Number 4, x minus 2y equals 4. I need to get that in slope-intercept form. So I'm going to subtract x on both sides. I want to get y by itself, so I'm going to divide everything by 2. Notice you can put a 1 in front of the x if you need to. I get y equals negative 1/2 x plus 2. So I'm going to go to 2 on my y-intercept, and then I'm going to go down 1 over 2, make my line. If you notice, both of these have the same, they're the exact same equation, y equals negative 1/2 x plus 2. So this is going to be the same line, and I'm going to have infinitely many solutions. All right, this one, x plus 3y equals negative 15, and y equals negative 7. So I need to get the first equation in slope-intercept form by subtracting x and then dividing everything by 3. So I get y equals negative 1/3 x minus 5. So I'm going to go down to 5 on the y-intercept, then I'm going to go down 1 over 3, draw my line. Y equals negative 7. All my y values are going to equal negative 7. So it's going to be a horizontal line going through the y-intercept at negative 7. So it's going to look like that. The point where they intersect is 6, negative 7. Number 6, the first equation is in slope-intercept form, so I'm going to go up to 5 on the y-axis. My slope is 1, so up 1 over 1. The other one, I'm going to subtract x. That leaves me with negative y equals negative x plus 2. Then I'm going to divide everything by negative 1 to get rid of that negative. So that gives me y equals positive x minus 2. So I'm going to go down to negative 2, and then my slope is up 1 over 1. So if you notice, they both have the same slope of 1. So if I have the same slope but different y-intercepts, I'm going to have parallel lines. And they're never going to cross, so I have no solution. Number 7, 3x minus 5y equals negative 35. I'm going to subtract 3x on both sides. I'm going to divide everything by negative 5 to get y by itself, and I get y equals 3/5 x plus 7. Now I can graph. I'm going to go up to 7 on the y-intercept, then up 3 over 5, and draw a line. The second one, I'm going to subtract 2x on both sides, so I get y equals negative 2x minus 6. So my y-intercept is negative 6. My slope, I'm going to go down 2 over 1. Draw my line. Look at the intersecting point is my solution, negative 5, 4. And number 8, x equals negative 2. Well, if it's an x equals, it's going to be a vertical line. So everywhere where x is negative 2, it doesn't matter what y is, but x is negative 2. So it's a vertical line going through negative 2 on the x-axis. The other equation, I need to put it in slope-intercept form, so I'm going to subtract 3x on both sides. I'm going to divide everything by negative 2. I get y equals 3/2 x plus 9. So I'm going to go up to 9. And then I'm going to go up 3 over 2, but I can't do that, so instead I'm going to go down 3, left 2. And then I can see that they're crossing right there. And the solution is negative 2, positive 6.